Today we're talking about polar coordinates, how to convert from polar to Cartesian. Cartesian is the same as rectangular, and from Cartesian to polar, and where those equations come from. Those equations basically come from right angle trigonometry. So you're going to have to understand sine, cosine, and tangent, SOHCAHTOA, and PT, Pythagorean theorem. If you don't understand these topics, I recommend you watch my videos on those. Otherwise, you can try and see if you understand what I'm talking about. So basically, you can start off by just drawing a circle, any circle, right? Draw your x and y axis, right? Remember, in a circle, the radius is the same no matter where you're on the circle, so we're just going to draw a radius from the center, of course, to a point here. I'm just using quadrant 1, it doesn't really matter. So then, this, of course, is the radius, right? We will let r. We're going to drop the height, right? Making sure we have a right angle with the x-axis. And the height of the triangle is the same as the y value. Y value is up and down, right? So the base of the triangle, we're going to label x, because x values are left and right, right? So here we can see we have a right triangle with three sides, x, y, and r, right? And we're going to label this theta because that's the angle. Theta is an angle, right? So now we're going to use our right angle trig. We're going to use sine. So sine of theta is equal opposite of our hypotenuse. Opposite is y, hypotenuse is r. So sine theta equals y over r, right? Then next we're going to use cosine. Cosine of theta. Cosine theta equals adjacent over hypotenuse. Adjacent x over hypotenuse r, so that's going to be x over r. Cosine theta equals x over r. Finally, we have tangent, TOA, right? So tangent theta equals opposite over adjacent, opposite over adjacent, y over x, right? Y over x. These are going to be the converting equations to convert from polar to Cartesian, Cartesian to polar. But there's actually one more, right? PT, Pythagorean theorem, x squared plus y squared equals r squared. X squared plus y squared equals r squared. These are the equations you need to know to convert from one to the other, okay? So then, what if we were to do an example, if we had 3 comma pi, and I forgot to mention this is polar coordinates, r comma theta, and this is Cartesian, x comma y, right? So this is polar coordinates. So how do we convert this to Cartesian or rectangular, right? You're going to basically use these two equations right here, and you're going to solve for the y value here, and you're going to solve for the x value here. If I solve for this y value here, I'm going to get y equals r sine theta, right? Multiply the r over. I can do the same thing for cosine. Multiply the r over. I get x equals r cosine theta, right? So these two equations are basically going to convert from polar to rectangular, right? This is all you really need to do that, right? So here, what's the y value going to be? The y value is going to be, what's the radius here? 3 sine pi, pi, right? Which is equal to sine of pi 0. Hopefully you understand that. 3 times 0 is 0, right? So how about x? X equals r, which is going to be 3 cosine pi. So cosine of pi, you should know, is -1. -1 times 3 is -3. This is the x value, this is the y value. So this polar coordinates here are going to be the same as these rectangular coordinates here, -3, 0. So these two are the same point. This is just polar coordinates, and this is rectangular Cartesian coordinates, right? So that's how you convert from polar to Cartesian. That was pretty simple, right? So what if we need to convert from rectangular to polar? So let's do an example like that. So what if we had the rectangular coordinates 1 comma rad 3, right? So in this instance, we're going to be using these two equations right here, right? So you got to remember these two you're going to use to go from polar to rectangular, and these two here you're going to go from rectangular to polar, okay? So here we will start off with this equation. So we can plug in the x and the y value, because this is x and this is y, right? So 1 squared plus rad 3 squared equals r squared. This is what we're solving for because we're trying to get to polar coordinates, right? So 1 squared is 1 plus 3 equals r squared, 4 equals r squared, r equals 2. That is our first coordinate. Bam, right? But now we got to do theta. That's what this equation's for. So then we're going to use tangent of theta equals Well, what's the y value? The y value is rad 3, and the x value is 1, right? So basically, you're going to have to use inverse tangent and figure that theta is basically equal to, I think it's 60 degrees, which is pi over 3, or 60 degrees. If you watch my other video, you're going to understand how we did this. So that's the angle. So our polar coordinates are essentially going to be 2 comma pi over 3 or 2 comma 60 degrees. Same thing, right? So that's how we convert from Cartesian to polar using these two equations, right? Polar to Cartesian, you want to use those two equations. But again, in order to understand where those equations come from, you're going to have to understand your right angle trigonometry, sine, cosine, tangent, and Pythagorean theorem. So hopefully that was helpful. If you are unfamiliar with any of the topics I mentioned, watch my videos on those topics. And if I was helpful, please like my video and subscribe to my channel. And if you were able to follow along, good job, and thank you for watching.